Before I start with the notes, I just want to do a quick introduction video explaining a little bit of background to inverse functions. Now, I'm sure you can remember that when we had sine of x is equal to a half, then if you wanted to find x, then you did sine inverse of a half. Now, you have been doing that. We've been using this term. However, we probably haven't really explained a whole lot about it. You just learnt a process. So let's have a think about it. What is happening when we take the inverse? For example, if you knew you had x as pi on 6 and you were taking the sine of pi on 6, you would get an output here of a half. So I'm going to call this input, and we would get this output. We often refer to our input, by the way, as our x value and our output as our y value. On the other hand, when we know that what the output actually is, for example, we know that we've got a half and we're looking for the input, then to find that input we take the inverse function. Now, trig is not the only place this happens. This happens with logs and exponentials. When you take the log, you're getting the power, you're getting the exponential. When you're looking for the exponential, you're finding you're finding the power. No, you're finding the value when it's raised to a given power. Exponentials, logs are inverse of one another. There's lots of other examples where one function is the inverse of the other. Squaring and taking the square root. So, you've seen inverse function operating before, where we go from, rather than knowing the input, we know the output and we're finding the input. It's almost like a bit of a reverse. Just a thing about notation. Please don't confuse sine inverse with 1 over. No, when we take this, when we've got sine of x, it is not sine, or even if I write sine inverse of x, that is not to be confused with 1 over the sine of x. No, that is not the case. We know that 1 over sine of x is actually called another trig ratio. It's called cosec x. That is not, we're not wanting the cosec of x when we are finding the inverse of x. We're trying to find what was the input of x. That would actually be an angle. What in sine inverse of x is what is the angle that gives a particular value, whereas cosec x gives me a value. It's not finding an angle. Hope I haven't confused you with that, but it's like the input here is an angle. Here, the output is a value. When we take the inverse, our input is actually the value, and we're finding the actual angle. So that's one thing to note about the notation. You really can't be confusing it with your previous understanding of an index to -1. You have to really focus on, this is a whole swap of input and output, which then takes me on to the algebraic form of an inverse function. In terms of the algebra, it's just exactly what I've described. We're going to swap the x and the y. So if we know that y is equal to 2x, for example, its inverse becomes x is equal to 2y. So that is the inverse function in terms of its algebraic form, and graphing it, if you think about this example that I've just presented, you can see now I've actually graphed in green the inverse function, x on 2, straight line through the middle. At 1 it'd be a half, at x is 2 it's 1. So I've also drawn y equals x, and I've drawn the original function, y equals 2x, or f of x equals 2x. Just a straight line through the origin, much steeper obviously than the y equals x on 2. The point of that is to show that an inverse function is obtained graphically by reflecting in the line y equals x. Y equals x. So graphically, we've got an understanding of what's going to go on with our inverse functions. We're going to take our original function and reflect every point across y equals x to the other side. Algebraically, we're going to swap the positions because our understanding of inverse is we're swapping from knowing the input and finding an output on a normal function to wanting the input knowing the output. I'll stop the video there and move on to the note.